Have you ever questioned the very fabric of the universe, what it's made of, its core building blocks? Traditional physics has long grappled with these questions, often finding limitations in its ability to fully answer them. But what if there was a theory that could push beyond these boundaries? A theory that might not just explain the universe, but redefine our understanding of it. Something as intricate, as fascinating, and as enigmatic as a string. Enter the world of string theory, a theory that might just redefine our understanding of the universe. Imagine for a moment that the universe isn't made up of particles, but tiny strings of energy. It's a challenging idea to grasp, isn't it? But that's the core concept of string theory, a theoretical framework within which the point-like particles of particle physics are replaced by one-dimensional strings. In conventional physics, we're taught that the smallest constituents of matter are particles. These particles, like electrons, quarks, and others, are considered to be zero-dimensional points. But string theory postulates a fascinating alternative. It suggests that these particles are not point-like at all, but are instead composed of tiny, one-dimensional strings. Now, you might be wondering, what exactly does this mean? Well, let's take a moment to understand this. Picture a violin string. When you pluck it, it vibrates and produces a sound, right? Now imagine if each of these strings of energy in the universe could vibrate just like that violin string. And here's the interesting part. The frequency at which these strings vibrate determines the kind of particle they form. It's like each string is playing a different note, and these notes come together to make up the universe as we know it. In essence, string theory proposes a universe that isn't made up of static, unchanging particles, but of dynamic, vibrating strings. These strings can vibrate at different frequencies, and it's these frequencies that give rise to different particles. Just as a stringed instrument can produce a variety of notes, the strings in string theory can produce a variety of particles. This is a radical departure from our conventional understanding of the universe. But it's a perspective that could potentially unlock new ways of understanding the fundamental nature of matter and the universe itself. But remember, while this theory is certainly fascinating, it's still just that. A theory. It's one of many attempts to reconcile the seemingly incompatible realms of quantum mechanics and general relativity. And while it offers some intriguing possibilities, it's still a topic of ongoing debate among physicists. So, instead of a universe made of particles, we have a symphony of strings, each string playing a unique note, vibrating at its own frequency, and together creating the cosmic melody we call reality. Now, what if I told you that our universe is not just the three-dimensional space we live in? Imagine that instead of the familiar three dimensions of space, length, width, and height, there are actually far more, hidden from our everyday perceptions. This is the astonishing proposal of string theory. You see, string theory is not satisfied with just three dimensions. It demands more. According to this theory, there are in fact 10 dimensions. Yes, you heard that right, 10. These extra dimensions, beyond our conventional understanding of reality, could be compact, curled up, and so tiny that they escape our detection. So why don't we see these extra dimensions? It's a bit like living on the surface of a very thin wire. From a distance, the wire looks one-dimensional, but up close you can see it has depth. This is the nature of our universe according to string theory. In the realm of string theory, we're not just living in a universe of width, length, and height, but a universe teeming with hidden dimensions. So why does string theory matter? What's the big deal? Well, let's dive right into it. String theory is a monumental step towards unifying quantum mechanics and general relativity, the two major theories in physics that have been at odds for the better part of a century. Quantum mechanics deals with the tiniest particles, while general relativity grapples with the grand scale of the universe. The two theories are like oil and water, but string theory might just be the emulsifier that blends them together. Imagine if we could reconcile these two theories. We'd have a single, comprehensive theory that could explain everything from the tiny quarks inside atoms to the vast expanse of the cosmos. This is the holy grail of physics, a theory of everything. And string theory is our best candidate yet. Beyond unification, string theory opens up exciting new avenues for research and potential applications. It could shed light on the enigmatic dark matter, that elusive stuff that makes up about 85% of the universe, yet remains invisible to our detection methods. It could also provide insights into the origin of the universe itself, offering a fresh perspective on the Big Bang. String theory, while still unproven, holds the promise of a truly unified understanding of our universe, a symphony of strings playing in dimensions yet unseen.